This slide is from 6.4 part 1. This is slide number 2 from the homework. Okay, a bunch of people were asking questions about this, so let's go. So this question asks us, how can you describe the rule that governs a pattern or a table? So part A of this asks, find a pattern by observing the change in X and the change in Y. So there's a bunch of different ways we can start to look at this. One thing we can start to do is see what happens as X changes, what happens to our Y values. We can see if we can just observe some patterns there. So in this table, our X's are not all in a nice tidy order, but we do have these values, X is 8, X is 10, and X is 12, which are really close together. So we can start to see some patterns there. So let's look at, between 10 and 12, between 10 and 12, X increases by 2. Let's look what happens between our Y's then. So when X increases by 2, our Y values go from 21 to 24. So Y increases by 4. And then let's see if that's true also for this 8 up here. So between 10 and 8, so when X is 8, I'm actually just going to make another little table just because it's easier for me when they are in order. So my X and my Y, when X is 8, Y is 17. When X is 10, Y is 21. And then when X is 12, Y is 25. So as our X increases by 2, our Y increases by 4. When our X increases by 2, our Y increases by 4. What this is doing is it is showing us that this is a linear relationship because there's consistent growth between our Y values and our X values. And if we wanted to find out more about what that growth is, we could look at, well, how are our change in Y divided by our change in X, or what is the unit rate of this graph? So we can say that as X increases by 4, Y increases by 2. So we know that every time our X increases by 1 then, our Y is increasing by 2. And we can use this to start filling in some of these other blue parts. So it could be a little bit difficult on this table, but one thing I like about this table is that just this work tells us that our situation is linear. If this is as far as you were able to get on this, that's okay. If the only pattern you can notice is as X increases by 2, Y increases by 4, that is a beautiful observation. That's fine. And maybe we can't fill in these 2 blue boxes using that observation, but we can definitely fill in some of these green ones. I could say, well then, when X is 14, let's increase our X's by 2. When X is 14, that means Y must be 25 plus 4, or 29. And when X is 16, let's increase that by 2 again. That means Y must be 29 plus 4, or 33. If that's as far as you got, that's fine. That is generalizing the pattern. We can look at this a little bit further, and once we identify that it is a proportional relationship, it's not proportional. Once we identify that it is a linear relationship, there we go, there's the right word, we can start to be like, well, that means that there is an equation that makes this situation true. we can start to look at, let's just check out this first coordinate pair, 8 and 17. When our input is 8 and our output is 17, what is the function that x is being input in where it spits out a 17? What are some of the mathematical things that can happen to 8 to create a 17? What I saw a lot of students notice is that, well, let's try what happens if you have 8 and you add 9 to it. That's 17. So there's one thing that could happen, but then we need to make sure that that's true for all of the numbers here. Let's test that with 10. What is 10 plus 9? That's 19. But our y when x is 10 is 21. So this rule of adding 9, it doesn't work. But what happens if, let's try to get our 8 close to 17. Like we can multiply it by 2. What's 8 times 2? If I take 2 and I multiply 8, that's 16. So what if I take 2 and I multiply 8 and I add 1? That's 17. All right, let's test it out for some other values. Let's take 2 and multiply it by 12 and then add 1. Well, it's 24 plus 1. That's 25. There's a coordinate pair. When x is 12, y is 25. Let's try for 10. If I take 2 and I multiply that x value, I multiply it by 10, then I add 1. Sure enough, I got 20 plus 1 equals 21. So if you had the brain juice to go that step further, you might find that your y values always equal your x values multiplied by 2 plus 1.